Hi lads, in this video I'm going to go through how to do the higher level 2012 section C-2 question. It tells us the 3D graphic on the right shows a fireplace in the form of a semi-hyperbola of revolution. The copper structure has been cut as shown to form a sloping top. A vertical opening accommodates the fire. Figure C2 below shows the plan and elevation of the fireplace. Part A, draw the outline plan and elevation of the semi-hyperbola of revolution, including the semicircular base. Part B, draw the projections of the sloping top in elevation and plan. And then Part C, draw the projections of the vertical opening. So to start off this question, I'm going to take my heights first. As it's a big enough kind of question, I want to make sure you can actually see it on the page. I'm going to start at my very top point, maybe just around here. What I'll do is I'll take my axis then, just as a random line running down through the centre here. So I'm told the total height of the hyperbola of revolution is 2000, and it's also a scale of 1s to 10, I forgot to mention that at the start. So if it's 2000, I'll take a 0 off that to give me 200. So 200 will take me to the bottom of that section there. And then I'm told to go down 10 and then 5, and that will complete my heights for my elevation. So that line there and that line there, and then I just have a gap in between for my plan, and the centre of my plan is going to start there. So the actual widths, if I take a 0 off that, gives me a diameter 140, which is going to be 70 mil radius on the compass, and this is for the widest part of the actual fireplace, the actual base of it. And that gives me a base there, and you can see all the way down to that point. That's okay. So after that then, I'm told that the actual base circles are a diameter of 120 when converted down, which means I want to take 60 on my compass there, and that'll be my base circle. And then my throat circle is going to be a diameter of 60, which is going to be taking 30 on my compass for the radius. And this is actually drawn in dashed. I'll just go around it lightly then afterwards. So there are all the circles I'm actually given in my plan. So I'm just going to take these points up here now for my actual fireplace, for the base of it. My base is going to be that little section here, the rectangle, and then the throat circle is also part of the base as well. It runs up through the centre of it. And that gives me these two lines here and here. And then finally, my base circle for my hyperbola of revolution is that circle there. So that's what I have for now. And I can also take that up to the very top as well to give me my circle at the opposite end of the hyperbola of revolution as well. Now, to actually draw the curve, first thing we need to do is we need to draw our asymptote. So we always know our asymptote appears as a tangent, or we get our true length of our asymptote appears as a tangent to the throat circle. So this line here, and we take that up, we get 1 point here and here for our base, and when they're taken up to the top, we get our point here and here, and where they join, they give us our asymptotes. So we have one asymptote here, and we have another asymptote there, and you can see that passes through the center of our axis as well. So now that we have our asymptote, we can actually start drawing our actual curve. So if I just take just a series of points here, it's a big enough curve, so I'm just going to take a few. So all I'm doing is rotating them around and taking them up. So for example, my first point here is on my asymptote line, so when it's taken up, it'll hit it here and there. The heights never change, so they come out like that. And when I rotate that around, it gives us a point here and there in our curve. And also I can take up my throat circle as well each side. So the curve is going to go no narrower than that point there, and take it up to the opposite side, go no narrower than this point here. So now I just repeat the process for all of my other points. And when this finished, I'll actually put it in colour as well, so just do all of them just to speed up the process instead of taking them one at a time. So you can see here, take this one up, that one I'm going to go out and across to give me this point here, and take it up to the top and across, and just dot instead of drawing the lines, I just dot where they are each time. So my third one is going to hit here and here, and they come out. They're going to give me this point here, this point here, and the last two will come out to that point there, and that point there, and they go up there. They're going to give me this point, this point, and then finally the last one, take this one right here in the bottom, take that up, give me that point there, and then my last one on the top, press that point there, take that across, give me that point there. So let's use a bit of colour to actually show one, for example. So I'll just use this one here. So that point, we take it up, and I'll just show it on the bottom half. We take that point up to hit our asymptote there. It goes across, and it stops where this line, which is rotating around here, hits it, and that gives me that point, for example, there. Just let it focus so you can see. And all that's left to do now is to actually draw in this half here first, and then what I'll do afterwards is I'll just step my widths across. So like that there, and I'm going to draw it all in lightly for now until I actually take my cut that occurs in this question. So just taking up all these heights here across. And then just step the widths of them. So that one there, across, and just redraw my curve and drawing lightly again. And my cut line occurs, I convert down, I go down 20 here, go down 70 here, that across is going to hit my curve here, this across is going to hit my curve here, so my curve is only going to appear heavy between that point there and this point here. And then just connect these to close off the top there of it. Now, to actually draw the curve and plan, what you need to do is you need to take a series of cuts. So if we take a series of cuts all along that surface area, a series of horizontal cuts, we're going to get a semicircle each time because it's a semicircle in plan. And when we take a semicircle cut, along that semicircle is going to give us a point along the curve where it actually cuts, and that's going to give us a point in our plan. So for example, if I just use the ones actually given to us here, let's say I take this one. I'll actually use colour to show you as well. If I take a cut, and I just imagine as if this cut actually doesn't take place here, I just take a horizontal cut with the whole surface. The radius of that cut will be out to the extreme edge there on the actual surface. If I take that distance on my compass, and you can take it down if you want into plan as well, I'm not going to bother with it. If I take that distance there, go down to my plan, I already have that already drawn in there. I'm just going to extend it around in case it goes further than where my actual asymptote line was taken. I'm just going to produce that semicircular kind of cut. You can draw it the whole end if you want, there's no need for it. We'll produce that semicircular line there. If that semicircle line hits the cut at that point, if I take that point down and where it hits that semicircle you draw, that's going to give me a point on my actual curve. And all I need to do is repeat the process with all of these ones here in between. So the extreme ones, they're easy enough, they actually lie on the extreme edge there, so that'll give me that point there, and the opposite one will give me that point there. So I already have 3 now, so I'm going to take this one next. So I already have that, already in my plan is that pink one I already drew, so I'm just going to extend it around a bit further. Hits the cut there, take that down, gives me that point there. Now I do the same with the next one. Take that distance there, already have it drawn in. So it's handiness of actually reusing lines you already have instead of creating more of them on your page. And then it gives me that point there, it's on the cut. And there's another point. Now you can see there's a big enough gap in between these 2 points and these two, so what I'm going to do is just create another 2 there myself, just in between. So I'm going to take that one there for example, take that distance on my compass, and I'm going to rotate that around there, and take it down to hit it. And that'll give me that point there, and then one more just in between these 2 surfaces here. Take that distance on my compass, and the point's going to occur on the left side, so I'm going to lark in there and drop this point down to meet it just there. and that'll give me enough points to actually go through and draw my freehand curve. And just go over it heavy. Just close off that section there. So that completes that part there. And all I'm going to do is just use my compass, see if I can just make this a little bit darker. Because the lead is very, very light in the compass I'm using. That there. And just so you can see where my throat circle is, I'll just go over it. Now the last part of the question tells us to draw the opening of the the fireplace. So it tells us it's up to 60 mil from that base point there, and that's given us our actual top point there. So to find that actual top point for the opening for the line going across there where the cut actually occurs, it's the exact same as the previous part of the question. What you do is you take that as a cut, and because it lies along the center point there, you can take this width here, and when you rotate that around there, so you're taking a horizontal cut again, take down your center point, and that gives you your cut there. So that line you're actually given in the question, you've given no point of where it actually occurs, that gives you that there, and that's going to be dashed in between. And that'll go across there, and where it hits your base circle there, that'll give you the opening points for the base. So it gives you your point there and your point there. And all it's a matter of doing now is to actually use, for example, these horizontal cuts here to give you points in between, say if you're redrawing them. So for example, if I take the top one here, I want to find all the points going on this side and step them across. I take that down, basically working backwards. Where that semicircle cut hits our line there, that gives us a point on the curve up there. So we're basically working backwards. Next one, this one here, take that, rotate it around, hits it there, take this up, get another point, and then this one here, exact same idea again, take it out, rotate it around. So all I'm doing is taking vertical cuts every single time. That'll give me that point there, and just I'll take one more in between here and here, just do an additional one as there's a big enough gap. Take that one there, rotate it around, hits it at that, hits it at that point there, take that up, and now what I can do is I can draw my cut that occurs in the opening there. I'll just use a bit of colour just to show that and highlight it. point. I took that green distance there, because there's the actual cut. I took a horizontal cut, hits the edge there, and when that came down, I just draw it in. It hits there, rotates around, tip my center axis there, and that gave me that line going across there. So I took that out, and down and around there, and that gave me my final center point to draw that line. And then just to show how I got one of my points, I would have taken that distance there, would have dropped it around, tip my line going across there to the actual opening, and then that would have been taken straight back up then where it hits that point there to give me a point in my opening then as well. So it's all about taking a series of horizontal cuts all the way across. And the last thing, just to finish out the question, is just to take my widths here and step them across each time. So it's going to be symmetrical. And then just draw in my curved surface there, and that then completes the question.